Equations and inequalities with absolute value. Suppose we wish to solve for x and we have the absolute value of x is equal to 5. To be able to solve this problem, we need to understand what it means to talk about absolute value. So the absolute value of x is defined to be the distance that the number x is from 0. So just imagine a number line. And we have 0 here in the middle. If I have a number x, the distance that x is from 0 here would be x units, right? Because x here is some positive number, and so it's just going to be that many units from 0. If I have a number over here, let's say it's equal to negative x, this is also going to be x units from 0, right? It's just on the other side of 0. And so if I have an equation such as the absolute value of x is equal to 5, then we need to ask ourselves, what number is 5 units from 0? And clearly it has to be 5 or negative 5, right? So the solution here is either x equals 5 or x equals negative 5. Now, I didn't really do anything mathematically to get this answer. It's just understanding the definition of what absolute value means. In the next example, we have the absolute value of 2a minus 1 is equal to 7. So again, let's think about this. If I told you the absolute value of x was equal to 7, we know the solution would be x equals 7 or x is equal to negative 7, based on the last problem. But now see, we don't have x inside the absolute value. We have 2a minus 1. Well, we approach it the same way. If the absolute value of 2a minus 1 is equal to 7, then whatever is inside of the absolute value, and in this case that is 2a minus 1, that number must be equal to 7, or that number must be equal to negative 7. And now all we need to do is solve each one of these equations. So if I add 1 to both sides here, we get 2a is equal to 8. And finally, dividing by 2, we end up with a equals 4. And if we solve the other equation, we end up getting a is equal to negative 3. And so we have two solutions. There are two numbers that will make this equation here true. Now in our next problem, we have the absolute value of 2/3 x minus 3, but then we have plus 5 and equals 12. Anytime you're solving an absolute value equation, what you want to do is get the absolute value by itself first. So we don't want this plus 5 hanging around out here. Let's subtract 5 from both sides. This will give us the absolute value of 2/3 x minus 3 on the left-hand side and 7 on the right-hand side. And now this problem is just like the previous problem. We have the absolute value of something is equal to 7. The only way this can be true is if whatever's inside the absolute value, in this case that's 2/3 x minus 3, must be equal to 7, or that thing must be equal to negative 7. And now we're just going to solve for x. So again, I can add 3 to both sides here. That's going to give us 2/3 x is equal to 10. And then to solve for x, I'm going to multiply both sides by the reciprocal of 2/3, which is 3/2. And on the left side, we get x. And on the right side, we get 15, right? Because what you're doing here is you're saying 2 goes into 10 5 times, and 5 times 3 is 15. Or 10 times 3 is 30, divided by 2 is 15. Now we can do the same thing here. Adding 3 to both sides here is going to give us 2/3 x is equal to negative 4. And then we're going to multiply both sides by 3/2. On the left side we have x, and on the right side we have negative 6. So again, two answers. In the next problem, it looks very similar to the previous three examples. We have the absolute value of 3a minus 6 is equal to negative 4. But I want to pause for a minute. Anytime you have a negative number over here, we need to pause and ask, is this possible? Remember, absolute value represents distance, and distance can never be equal to a negative number. So the answer here is no, this is not possible, and therefore there is no solution, okay? And so anytime the absolute value is equal to a negative number, that simply can't be true. In our next example, we have the absolute value of one thing is equal to the absolute value of another thing. Now let's think about this. How could this be true? So let's suppose I gave you a simple equation. What if I said the absolute value of 5 on one side is equal to the absolute value of something else on the other side? It should make sense that whatever's in here would have to either be 5 or negative 5, right? Because we know the absolute value of 5 is 5. So in order for these to be equal, we would have to have the absolute value of 5 on the other side, or we would have to have the absolute value of negative 5 on the other side. So what does that mean over here? We don't have a number, we have two variable expressions. Well, one way these can be equal is if the thing inside is actually the same. So one possible solution would occur when 3a plus 2 is equal to 2a plus 3. That's one possibility. The other possibility would be when 3a plus 2 is equal to the opposite of 2a plus 3, right? Because if these numbers are opposites of each other, the absolute value will make them the same. So now we just have to solve each one of these. So here I'm going to subtract 2a. This gives us a plus 2 is equal to 3. And then subtracting 2, we get a equals 1. And on the other one, we have 3a plus 2 is equal to negative 2a minus 3. Adding 2a to both sides gives us 5a plus 2 is equal to negative 3. Subtracting 2 from both sides, we get 5a is equal to negative 5. And finally, dividing by 5, we get a is equal to negative 1. And so here we have two possible solutions once again. So this example is just like the last one. We know we have two possibilities here. Either x minus 5 must be equal to x minus 7, or x minus 5 must be equal to the opposite of x minus 7. Now the interesting thing here is when you go to solve this first equation, you get negative 5 is equal to negative 7. And of course, this is not true. So there is no solution to that equation. However, in the second one here, if we distribute the negative, we get this. And then if we add x to both sides, we get 2x minus 5 is equal to 7. And then adding 5 to both sides, we get 2x equals 12. And finally, dividing by 2 gives us x equals 6. So in this case, there is only one solution. So we're going to start talking about absolute value inequalities. And that's a little bit more complicated. So first, let's summarize what we have already talked about. If you have the absolute value of x is equal to c, and we'll suppose that c is some positive real number, the way you solve that is you set x equal to negative c or x equals positive c. And that's what we did in most of the examples that we just looked at. And of course, a slightly more complicated version would be if you have the absolute value of something like ax plus b is equal to c, you are going to set ax plus b equal to negative c or positive c. But what if we have an absolute value is less than c, or an absolute value is greater than c? How do we handle these cases? Well, you can see here, this is how we handle them, but let's talk about why this is what we do. So first, let's just talk about the absolute value of x is less than c. Remember, absolute value means distance. So if the absolute value of x is less than c, this means that x is a number whose distance from 0 is less than c units. Think about what that looks like on a number line. Here's 0. We know the number c is c units away from 0, and we know the number negative c is c units away from 0. So what does x have to be? X has to be a number whose distance from 0 is less than c units. This means that x has to be a number in here. It cannot be more than c units away from 0. So it means the solution would be all the numbers in between negative c and positive c. So the solution is x would have to be a number bigger than negative c, but less than positive c. And that's why they get this up here. Okay, now the same thing is true for this one. This is the exact same situation. It's just that now instead of having an x inside, we have ax plus b. Okay, but that's the same reasoning. You're just putting ax plus b here. So let's go ahead and talk about a couple of examples of that, and then we'll come back and we'll talk about how we deal with this situation. So to solve the absolute value of 2x minus 5 is less than 3, we know that the number 2x minus 5, whatever it is, has to be in between negative 3 and positive 3. Now, when I say it has to be in between, notice how both inequalities point to the left, right? Because on the number line, we're saying that it has to be bigger than, right? Bigger than negative 3, that's over here, but at the same time has to be less than, right, positive 3, that's over here. So the solution would be all the numbers in here. Now, of course, that's not the final solution. This is just the setup. To get the final solution, we have to solve for x here. So to solve a continued inequality like this, we're just going to add 5 to all three of these. This is going to give us 2 is less than 2x is less than 8. And then we can divide by 2. And that will give us 1 is less than x is less than 4. And so our solution here, the graph, is all the numbers in between 1 and 4. And we're not including, right? Because there's no equal to on our less than symbol. So in interval notation, our final answer here is all the numbers from 1 to 4, not including. Now, both of these are acceptable answers, here and here. You just have to make sure you answer the question in the way that you're being asked. So for this next one, we're now talking about the absolute value of something is greater than or equal to 9. So let's go back and interpret, what does it mean to be greater than or equal to something? So if you recall back here, we said that if the absolute value of x is less than c, we have to be in between negative c and positive c, right? Because less than means the distance has to be less than c units, so it has to be close to 0. But what if this wasn't less than? What if instead of this, we had the absolute value of x is greater than c? Well, now the distance is not going to be less than c units. It's going to be more than c units away. And so now the solution is not going to be all the numbers in between negative c and positive c. It's going to be all the numbers bigger than c out here or less than negative c. So the solution is either x is less than negative c or x is greater than positive c. So it's the opposite of how we set it up when it was less than. But notice that when it was less than, so I'm looking up here now, when it was less than, we could write that solution in one single statement. We wrote our solution like this. But when it's greater than, you have to do two separate inequalities with the word or in between. And that's because there's two sets of numbers that don't touch each other. Okay, so let's go back to our problem now. We want to solve the absolute value of 4t minus 3 is greater than or equal to 9. Let's think about what it means for an absolute value to be greater than 9. So let's say here's the number 9 and here's the number negative 9. If the absolute value were less than 9, it would be in here. So if it's greater than 9, it has to either be out here or it has to be out here. So our solution is going to be all the numbers less than negative 9 or greater than positive 9, okay? So do we agree that these numbers here are x is less than negative 9 and these numbers are x is greater than positive 9? All right, so how do I set up this particular problem? Well, we don't have x, we have 4t minus 3. So it's just 4t minus 3 must be less than or equal to negative 9, or 4t minus 3 has to be greater than or equal to positive 9. Now, why did I put equal to? Well, because the original problem had equal. Okay, so if the original problem has equal, then you just include it down here. Okay, so now we just need to solve each one of these. Here I'm going to add 3. And that gives us 4t is less than or equal to negative 6. Then we can divide by 4. And we get t is less than or equal to negative 3 over 2. So that's one possible answer. Or the other possible answer, if I add 3 to both sides here, we get 4t is greater than or equal to 12. And then now dividing by 4, we get t is greater than or equal to 3. So on our number line, our final solution, the solution for this particular problem, is going to be all numbers less than or equal to negative 3/2. So that would be all the numbers this way. Or all the numbers greater than or equal to positive 3. That's all the numbers this way. And so now in interval notation, that would simply be negative infinity up to negative 3/2, including, or, which means union, 3 to infinity. In our next example, we have the absolute value of 2x plus 3 plus 4 is less than 9. So again, when you're solving an absolute value equation or inequality, the first thing we want to do is get this absolute value by itself. So we're going to subtract 4. And that will give us the absolute value of 2x plus 3 is less than 5. Now it's less than. So less than 5 means that whatever the number is, it has to be within 5 units from 0, right? So it has to be between 5 and negative 5. So 2x plus 3, whatever's inside the absolute value, must be in between positive 5 and negative 5. And then we solve. So I can subtract 3 from all 3 parts here. This will give us negative 8 is less than 2x is less than 2. And then divide everything by 2. We get negative 4 is less than x is less than 1. So here's our solution. Now the graph of this solution would be all numbers in between negative 4 and positive 1, not including, right? And so now in interval notation, that would look like this. Now again, you might be wondering, well, why did you draw this graph if that's not the answer? Well, what I was doing is I was trying to understand how to set up the problem, right? You have to remove the absolute value before you can solve it. That's really important, right? So we have to interpret, what does this mean without the absolute value symbols? Once you remove the absolute values, then you can solve things like normal. Okay, in our next one here, we have the absolute value of 4 minus 2t is greater than 2. So what does it mean for the absolute value of something to be greater than 2? Well, it means that it has to be more than 2 units away from 0. Right? So it's got to either be out here or out here. So whatever's inside the absolute value, in this case we have 4 minus 2t, that has to be less than negative 2, or 4 minus 2t has to be greater than positive 2. And now we're just going to solve this. So if we subtract 4 from both sides, and then divide by negative 2, so remember, when you divide by a negative, it's very important you remember to switch the inequality symbol. So we get t is greater than 3, or the other one here, if I subtract 4, we get negative 2t is greater than negative 2, and then divide by negative 2. Again, when you divide, you have to switch the inequality, and we get t is less than 1. So on a number line, remember, here's 1, here's 3. Greater than 3 is over here. Less than 1 is over here. So in interval notation, we have this. Now our last two examples are special examples. So notice here you have the absolute value of something, and it says less than negative 2. Remember, the absolute value of something is always a positive number, right? Absolute value is a positive number. When is a positive number less than a negative number? Never, right? This is never true. So there is no solution here. Okay, it's just not possible. So what that means is no matter what you plug in for y, no matter what number you let y be equal to, this is never going to be true. In our last example, it's just the opposite. We have the absolute value of something. Once again, absolute value of something. This is always going to be a positive number. But now it says it's greater than negative 5. Well, ask yourself, if this is a positive number, when is that going to be greater than negative 5? This is always true, right? Because an absolute value gives you a positive. So no matter what you plug in for x, and you do the math here, this is always going to be bigger than negative 5. So when it's always true, it means the solution is all real numbers. And that, of course, means all the numbers from negative infinity to positive infinity. And that concludes this video lesson.